next talk I'm really excited about. One of the things I care about as an organizer, when I'm thinking about a conference, I care about having kind of a smorgasbord of talks and topics. So there's something for everybody here. And this talk feels like, to me, I haven't seen it yet, but I think is the most Rubyist, the Rubyist talk of the conference. And so I'm really excited about that. I'm also excited to welcome Ifat Ribon back for the second time as a second-time speaker to Blue Ridge Ruby. Her talks are always fantastic, and I think this is going to be a blast. And she's speaking about Ruby's secret talent for improvisation. I'm wondering if she's going to be talking a little bit about her own talents in improvisation, potentially. Let's give it up for Ifat.
Thank you. Thank you very much, Jeremy. Yes, welcome everybody to my talk, Yes and Ruby's Secret Talent for Improvisation. So to begin though, I'd like to try something together. What I'm going to do is we're going to build a story together. I'm going to say a line, and then I'm going to pick on somebody in the audience to say a line back. And there's only one rule for that line back, is that it has to start with yes and. So with that, I might say something like, I've only been at this conference for 2 hours, and I've already committed to about 3 side projects. And someone else might say,
yes, and Ruby Events is one of them now.
Yes, and Ruby Events is one of them now. Beautiful. You nailed it. Thank you so much. You nailed that yes and, which is, for some of you, you may have just seen your very first improv scene, so you're welcome. And you've also seen the #1 rule of improv, which is yes and. And maybe some of you have heard that before. But this is a very foundational principle of improv, and as we're going to see, of Ruby as well. What yes and really means is that you accept what's given and you add something new. You build on the offer from your scene partner, and you create something out of nothing. That's just like writing a Ruby app. A little bit about me. My name is Ifat Ribon. I currently live in Chicago, actually down the street from Second City, where I spent years learning and playing improv. By day, I am a principal architect at Launchpad Lab. We're a small agency headquartered out of Chicago. Among the many roles I play at Launchpad, I'm still very immersed in writing Ruby and shipping apps to production. I'm really excited to show how I've seen these two worlds really come together, and how Ruby isn't just flexible, but it's also designed to invite the collaboration that is so fun about improv. With that, let me introduce some of my scene partners. We'll play a little bit with 3 of Ruby's functions, which are blocks, procs, and lambdas. We're going to see how each of them play on stage, and how each of them adhere to, or sometimes don't adhere to, the foundations of improvisation. We'll see how they pass control, how they accept what's given, and how they play to the absurd. To begin, let's keep working with what we already saw today, yes and how we pass the mic between us to build a scene. We're going to see, first of all, how Ruby does exactly that with blocks. To begin, there are a lot of truths in improv, and one of those truths in improv is that only one person speaks at a time. Listening is imperative in improv, because if you can't hear or can't listen to your partner, you're going to have a really hard time offering that yes and back and building something meaningful and hopefully funny together. So the idea is that when you're on stage with another person, you hold the spotlight, you provide your contribution, and then you pass the mic and the focus to your partner. Ruby does something very similar with blocks, and I imagine most people here are familiar with Ruby's blocks. This is one of the traditional notations, right, with the do and end keywords. The expression between those keywords is the block itself. In this case, we're going to evaluate a simple put statement and print out a sentence. The scene method is a method that we defined. And what's really cool about blocks is that you can pass them to any method at all. And it's up to the method to figure out if they want to use it, how they want to use it, and how to proceed. And that's very, very powerful in Ruby. So let's take a look at what that scene method might actually look like. So this is my scene. We might set the stage with an offer or a prompt. Then we're going to use Ruby's keyword yield, and then we'll continue the scene. This keyword yield, that's really all you have to do with it. You can pass arguments, which we'll see later, but that's a signal to the method that it's receiving a block and it should go do something with it. You can also skip the yield or guard against blocks as well. So let's see this a little bit in action. And this is the other notation for a block, right, is you can call your method and then pass the block through with curly braces. If we'll see this come out, we'll see that first statement come in, the offer, the thing the method wanted to set the stage with. The client wants a small change. The block will come in and add to it. Sure, I'll just move this button around, and I'll pass it back to the scene. The scene will continue with that, and it might escalate it, right? It took down staging prod and the Keurig somehow. So that's a little bit about how I've been thinking about Ruby's yields, is that it's kind of like a conversation. And we saw a little bit of that with Joelle's talk as well, right? This idea of kind of stateless back and forth. And that can be really powerful to use things like blocks. So just to reiterate what we had here, in our method, we set the scene, we pass off to the block, and we continue it. Well, what if we wanted to continue the scene even further and pass it back to our blocks? Well, we might get a bit of an error. The scene's not going to work. It's going to kind of fall flat. In Ruby, it indicates this with a syntax error, an unexpected braces, expecting end of input. It's saying that the scene wasn't expecting to continue anything at all after that. It was ready for the lights to go down. And here, Ruby is kind of showing us its intentional design, that blocks by their nature are anonymous, they're ephemeral, and so they're only meant to be called, evaluated once, and move along. So why couldn't it call this twice, right? Say you listed yield twice, and you're like, well, why can't it just assume that it's the second one? And that's because of that anonymous nature. The yield doesn't know which block you wanted to use. Is it the first print statement, or is the second one? It doesn't have a name, and so there's no way to refer to it. And that's why we get this error. Well, what if we did want to give it a name? We could do that with some special operators. We can give our block a name and pass it in as a parameter to our method. And the way that we'll do that is with the pink ampersand operator, which you see here. What this operator is really doing under the hood is it's giving the block a bit of a costume change. It's saying, you're not really a block anymore, you're actually a proc, which we're totally going to get into next. A proc behaves a little bit differently, and one of the ways that it does so is that it can be stored in a variable, and it can be passed around as a piece of data. To go ahead and use that, you could certainly use the yield keyword again here. You could yield scene partner. But because it's a proc, and a good way to remember as such is it's conventional to use the call method, which we'll see much more of. That's generally how you call procs. So it's good practice to also do that to keep reinforcing the idea that this block is really acting like a proc in this case. Okay, well, we've named our scene partner, and now we get to call it again. What if we tried to give it 2 scene partners and make a bit of a group scene? We could do something like this. We could give it a shot. I could write this method down, and I could put it in my console, and Ruby won't even let me start the scene. I get another syntax error. In this case, unexpected comma, expecting closing parentheses. It's only expecting you to provide a named block once. And furthermore, it's got to be the last parameter. So in this example, if I wanted to add other parameters, I'd have to do that before the block. This really enforces what we talked about in terms of this is by design and intentional, to use blocks once. Just like improv, you use it, you see it on stage, and then you're never going to see it again. And that's the beauty. And that's exactly what Ruby reinforces, right? You got one method at a time, you can pass one block at a time, you've got one mic to share between you. So let's talk about another premise of improv, which is accepting the offer. And we're gonna see how Ruby's functions do this with the way that they handle arity, which is the number of arguments that they can take in. Before we do that, I'd like to do another small bit. And again, I'm gonna say a sentence. I'm gonna have someone in the audience help me out with that. However, this time, the response has to start with no. All right? So I might start a story with, I just found out I'm getting a kitten. No. Beautiful. No. And that's the end of the scene. Amazing. Thank you for being my guinea pig and showing us how that scene ended very quickly. There was nowhere to go from that. This shows us another truth in improv. Never deny the premise, but thank you for doing that for me. Ideally, on stage, you accept what your partner offers you and you work with it. Now, you don't have to work with everything they said. You might take and choose what you want to work with, but you don't want to deny the premise, because as you can see, you're not gonna have much of a scene. You will get a laugh sometimes, but it might not work every time. So let's see how Ruby works with this premise. So let's keep looking at blocks and that yield keyword. So in this case, like I mentioned, yield can also take arguments in. And when you define your block, when you're ready to pass it into the method, you can define the parameters that it may use. And what's really cool about blocks is they're really chill and flexible. In this case, I might define my block there on the bottom with just one parameter, a line. Again, I might just print that line, that's all I want to do with it. My scene partner might want to give me a couple bits of information. Might want to give me both the offer and the escalation point. But I'm not ready for that. I'm not ready to heighten the scene just yet. I only want to put forward one thing. Blocks do this really well. They simply ignore any extra arguments. And that's totally fine. They can still move the scene along perfectly well. What I do want to point out is that that parameter in the pipes there, which is takes the place of the arguments the block will take in, can be called anything at all, right? Just like variables, they're stand-ins for the things that they'll receive. Because blocks are so flexible, this works in the other direction as well. For instance, maybe our scene isn't ready to escalate just yet, and we only want to pass our block the initial offer, but our block was really ready. It was willing to accept both the line and the punchline. That's okay. It didn't receive the punchline just yet. Blocks are still chill. They'll just assign nil, and they won't do anything at all with it. This won't error out. You'll just get whatever was used. Now, if you are trying to do something with punchline that nil does not respond to, you will certainly get an error, but that's on you as a bad scene partner and not on Ruby and yield. All right, so let's see how this might kind of be useful. I alluded earlier that you couldn't pass multiple blocks, but you can use the block multiple times in an argument. There's not a ton of use cases for this, because as you can imagine, it might start to feel a little bit repetitive. For instance, in this case, taking what we saw about blocks argument flexibility, maybe we do call yield twice, and the first time around we do only pass the offer, and the next time around we only want to pass the escalation. This example gets a little bit weird because we kind of have to insist on passing nil first so that the statements kind of work out. You could imagine if I passed offer first and then offer escalation second, that we'd get I'm playing pickleball, and then again, I'm playing pickleball, and the ball's made out of cheese, right? So it's kind of a weird example, and you don't often see yield getting called multiple times, but there's no reason why not. Some other use cases could be that you might want to do something a bit more recursive or stepwise. You might want to capture the result of your first yield and pass it back into the block to do something else. That could be an interesting use case. We talked a lot about blocks. They've had a lot of limelight so far. So let's bring our other partners on stage. We've got the proc and the lambda. And I know it's pretty common to forget kind of the difference between them. A lot of people know what they are or have seen them, but they can't quite remember the differences. So I'm hoping this helps a little bit. The way that I think about procs and lambdas are two different style of players. In improv, you have long form play. It's where you're really building a scene over time, over a whole half hour, an hour. Or additionally, you might have improv scenes that are more game-based. They're very rigid with their structure and very specific with their rules. And each of our scene partners kind of have a tendency to go for one or the other. Procs, they're kind of the loose improviser. They really love the long form. They love that space to play and evolve and be really flexible. And sometimes that can be really fun and funny, and sometimes that can kind of get us into trouble. The lambdas, however, they're by the book. They really thrive in those improv games where they've got exact rules that they can hit for their beats. So, to see this a little bit in action, a proc, to introduce it, is a first-class object in Ruby, and you can create a proc by instantiating it with proc.new. All proc is an object that encapsulates a block. That's why it looks exactly like what we saw earlier with blocks. You define it the exact same way with your parameters and pipes, and you can do whatever you want with those parameters inside the block. As I alluded to before, the conventional way to use a proc or to evaluate it is to call the call method. There are a lot of other fun ways to do it, and that could be a whole other fun improv talk or maybe Drew Bragg's talk, but for now, most times you'll see it called with call. As we saw before, because procs are essentially just encapsulating blocks, they behave much like blocks in that they are also quite flexible. Just like with the block, if the proc doesn't receive all of its arguments that it defined, it'll just ignore them, and that's okay. So in this case, we're only passing in one, and we'll get a perfectly fine evaluation with that sentence. Well, let's see how lambdas handle that. So lambdas are actually a type of proc, and what's really happening under the hood in Ruby is that there's a flag that says, this is a lambda, and now it has other special behavior. The way that you define a lambda, like most things in Ruby, there are a lot of ways to define the same thing. You can use the lambda keyword, which I'm not showing here, but it would look a lot like our proc example, where we'd have the pipes and the expression that encapsulate the block. The more conventional way right now is the stabby lambda, which is the term for the arrow you see there in pink. And with that, I used to get this confused all the time, but with that, you actually define its parameter list outside of the enclosing braces, and you do it in parentheses. And the way I finally remembered this is by realizing that lambdas behave a lot more like methods, and that they're actually very strict about the arguments that it receives. For all intents and purposes, this lambda looks a lot like the proc we just saw, but if we don't pass in the right number of arguments, it's going to complain. It's going to tell us we didn't play the game right and it wasn't funny enough for it, right? So Ruby will give us an argument error and let us know. This can be quite powerful to mitigate the risk that the proc is going to be a little too fast and loose and not use something that you wanted to use. And so lambdas are quite common in Ruby. In Rails, for example, you've probably seen them a lot in scope definitions. That's where I've seen them a lot. And that's because you'll get a really early notification around something that went wrong if you didn't quite use it right. To that end, then, why wouldn't you just use a method? Well, we totally could. Of course we could. We could, for instance, create this method called perform that takes a character and a scene, and we might want to have that character interact with some scenes. If you did that, you would have to pass in that character every single time, and it would feel a little bit repetitive over time, right? A lambda, and for what it's worth, the procs and blocks, what's really interesting about them is that is this concept of lexical scope, the idea that they have access to the scope that they were defined in. And what this means in practice is that in this case, we could rearrange the method we saw before and use a sort of a factory pattern here. Perhaps we have a bit of a factory, a method around creating our performer with our character, our man in black. The lambda then will just accept the scene, and it will happily put our character into any scene you give it, remembering exactly who that character is. So what that looks like is I could call my create performer factory, and maybe I want to save it to a variable. I now have my Dread Pirate Roberts available to me. And then I can go ahead and call, because lambdas are just procs. They also use the call method. And I can send my man in black into all of the awful places that he has to go through just to find his true love, Buttercup. So you might be able to see how lambdas are very useful in composition, and you see this a lot with operations that you might want to have slightly different configurations. You might want to format certain things that look similar, but you want to format them differently, and you might want to capture the original input first and then do something else with it each time. So we showed a lot of examples of control flow, how Ruby allows you to have this back and forth within your methods, how it allows you to encapsulate behavior rather than data and pass that around. And we introduced the idea of lexical scope and this idea that these functions have access to the scope in which they're defined. Well, let's see when it gets just a little bit weird. So in improv, when a scene is over, what happens is someone sweeps the scene. That's the term. And sometimes this is a very physical sweep. Someone literally runs across the stage, or in other cases, you might see someone tap someone in and out. That's called sweeping the scene and moving on to the next scene. The thing about this is that, like everything else in improv, it's unpredictable. There are no rules about when to sweep a scene. It's all about your offstage scene partners, your in-scene scene partners, and how they feel the scene is going. So a lot of times they can sweep it after a really big laugh, and you really end on a high note, and that's great. And other times that scene is kind of just falling apart. You can hear crickets in the audience, and it doesn't feel good, so you might sweep it then. The problem is, the idea is that the lights go down whether you are ready or not, and you gotta get off stage. So let's see how our players sweep their scenes. We're gonna come back to the lambda since we just touched on it. Lambdas are by the book players. They're gonna hit all the beats, and it's very predictable. That makes them really easy for them to exit very gracefully. So what happens is, say we have our scene method, we have our offer, which is our initial expression that we're gonna evaluate in the method. We're gonna define, in this case, the lambda inside the method. Again, just a simple print statements, but we're gonna have a very explicit return. Then we're going to invoke our lambda, and then we're going to attempt to finish the scene. So how does this play out if you were to run this? Call our scene method, and you've got the setting the stage that the first method, the method initially did. The lambda comes in with its response and contribution, and then the scene continues. We made it all the way to the escalation and the punchline. Amazing, lots of laughs, beautiful, lights go down exactly when they should. Let's see how procs do this. So procs, like I alluded, they play a little bit fast and loose. They don't really care about arguments. They go with the flow. Same exact method, just with a proc. And here's the other notation that you might see for a proc, which is a lowercase, essentially an instance of a proc. You can call it this, instantiate it this way as well. Let's put an explicit return in there as well, just like we did with our lambda, and let's see what happens. We've got our setting the stage, our initial offer. Proc comes in beautifully with its contribution. And the lights go down. Woof, we never got the payoff. How unsatisfying. So why is that? So with procs, what they do is they return outside of the scope in which that they're defined. In this case, we define it in the method. Well, what if we define it outside the method? For whatever reason, maybe you're within a class or something like that. We're gonna do something very similar to what we just did, except for we're gonna define that proc outside of our method. We're gonna save it to a variable so we can pass it in. We're gonna invoke it in the middle there, and we're gonna see what happens. Scene sets the stage. Proc provides its contribution. The whole audience leaves, just runs out the door. It's over. And this is a very unfortunate behavior of procs. Because they return to the scope in which they are created. If you create them even more outside, in this case, in the ether, in my example, they have nothing to return to. And that's why you get this famed local jump error. It may not be super common, because once you hit it once, you quickly look up why, and then you never do it again. Ruby tells us exactly what's happening here. We had an unexpected return. We weren't expecting to finish the scene so early. if you take nothing away from this talk, I hope you can remember this difference. Lambdas, they love to play in the scene, and they provide their contribution, and then they say, I'm done. The scene continues. The proc provides their contribution, and they say, we're done, and it's over. So let's bring it all back. There's no way to end an improv scene like having a bit of a callback. I think of Ruby a lot as your scene partner in all the ways that it offers you to be really creative with your code, the way that you can reuse code with functions, whether anonymous and ephemeral like blocks, or captured and repeatable ones like your procs and lambdas. The idea is that you're going to hold the focus and you're going to share the stage with those scene partners, and you're going to pass it off to them, let them do their work, and then bring it back. Those functions are going to build on what's given. You give them too much, too little, depending on your player, you'll get exactly what you need. And finally, return with intention. Know your exit. Look for exiting on those high notes, and don't inadvertently kill your scene before you get to the punchline. With that, Ruby really rewards the improv mindset, and it's one of the things I love the most about it. So, yes and is exactly what Ruby does. It doesn't just run your code, it listens, accepts the offer, and says yes and. Thank you very much for listening, and tickets are $5 at the door. Thank you.